In this session we will cover the digital terrain model, or the DTM tool. Our objectives here are to show you how to access the DTM tools. We'll do a review of all the tools in DTM. We'll create a TIN file. We'll display the DTM features such as contours and triangles, and we'll also use various analysis tools that are located in the DTM tools. So let's go into a MicroStation file and look at how to access the DTM tool. In V8i we have our DTM tools are located over on the left hand side in our toolbar, and we have all of the tools that we need to create a TIN file over here in this menu. If you'll notice, we have the stroking options, extract graphics, all the tools that are necessary. We're going to look at stroking option first. And what stroking option does is it gives us the ability to set or add additional points. For instance, if we have a curve and we don't think that there's enough points that have been created or added to correctly or accurately define that curve, we can go in, select this, put a check mark here, then we can go in and put a distance and say what that's telling Geopak is if you go this particular distance and you don't find a point, then we want you to add one. And you can do that for curved or for linear distances simply by toggling this on and putting a distance in that area. Now the next tool we have is Extract Graphics. And Extract Graphics is the ability, or gives us the ability, to go into a 3D file. And if you'll notice, this is a 3D file. This is information of our existing ground. We have first of all, they ask us for a file name for our DAT file. Now we're going to create a DAT file, XYZ information from information from the 3D information that's located in this file. We're going to extract that information into a DAT file, and then we're going to use that DAT file to create our TIN file. So we're going to give this a name, and we'll call it class.dat. Give it whatever name you really want to. It really doesn't make any difference. We have two file types. We can do this ASCII or binary. We're going to do it ASCII because then it will give us the ability to actually open this file up and look at it if we want to. The first thing, we have file open options of create and append. Initially we're going to create this file, and then we're going to come back and append or add additional information to that. Now the reason that we have to do that is that if we go to the feature tool, the feature option here, you'll notice that we have multiple features. But we can only add one of these features at a time. And so we're going to create this file called class.dat, and we're going to first of all put in spot elevation or spot shots, and then come back and append it with other information. We have two modes, extraction and interpolation. We normally use extraction because we found that interpolation really creates too many unnecessary points. Now we have what's called search criteria. This is simply to allow us to tell Geopak what to look for in the file that represents spot elevations or spot shots. And so we're going to toggle all these on. We're going to do a reset to clear this area. We're going to zoom in to a particular area where I know that there are spot shots, these little white dots on the screen. We're going to do match. Select the match button, come in, select that, well, just one of those spot shots, and you'll notice that once I select it and hit a data point, it puts that information into this field for me. Now if I want to do display, It's hard to see, I'm sure, on the screen, but they're highlighted, and now I have to hit undisplay and make sure that they're back in their original color. Now, once I've done this and I've got the extract feature set to view 1, you'll notice that I'm in view 1, but if I hit not apply right now, the only information I'm going to get is what's contained in this particular view 1. So if I want everything in the file, what I have to do is come up and hit a fit command and put the entire area in view 1. Now once that's done, all I do is hit apply. And it's created a file called class.dat. Now if I wanted to look at that file, I can go right here to my text editor, and I can say open, and we have a file called class.dat. Open that file up, and you'll notice that we have 1 on the left hand side, and we have the X, Y, and Z information of all the spot shots. Now the 1 is simply a number that tells Geopak what the numbers to the right represent or identify. In other words, the 1 here in this particular case, 1 stands for spot shots. So it's telling Geopak that this information to the right of this number represents a spot shot on the ground. We'll see that once we get into putting in break lines, that those will be represented by 2s and 3s. The 2s will be the beginning of a break line, and the 3s will be shots along the break line. Okay, these are really not of any significance or any importance to us, but they do tell Geopak what those items or numbers on the right represent. Okay. So once we have that information and we've created this file, we've input the spot elevation information in there, then we're going to go change this from create to append, because we're going to add information to this file. And the information we're going to add is breaks or break lines. And we'll zoom into this area again. We'll do a reset to clear all this information out. We'll do a match. We'll select this line, accept it, and select all these lines and accept them, and it's putting that information in the area, and we want to make sure that we have everything. So what we can do is say display, and it's going to display everything that's shown here in this field. So we hit display, and you can see that most of the lines have been chosen or highlighted. Once again, we have this information in here. We're looking at view 1, so we have to do a fit on view 1, and we're going to do apply. And now all that information has been placed in the excuse me, in the DAT file. So the next thing we're going to append or we're going to add is voids. Now the voids are areas, and I probably didn't explain that, but the break lines are areas, lines that define like the edge of pavement, top of ditch, things like that. The voids are areas where they could not get any data. For instance, a wooded area that has not been cleared, they will take shots around that area. Or a pond, they will take shots around the pond. It's just areas that have not, they could not get information from. And so I'm going to move up here close to the top because I know there's some void areas here. And I'm going to do a reset, clear all this out. We've got ours set to append and void. And I'm going to go in and do a match. And we're going to match the larger areas, and we'll do display, undisplay, and we've got those. And if we zoom out, we'll see that we've also got that one over here. And so we've gotten all the void areas. Do a fit, do apply, and we've gotten all the voids. So once we have all of this area, once we have all of this information extracted from this 3D file and placed in that class.dat, we'll look at some of the other tools. We've got something called extract XYZ. Now this is in case you get one of these DAT files from a surveyor that already has the XYZ information in it. You can use the extract XYZ, and you can go in and pull that file in here as far as the input file. The output file would be class.dat. Once this file is loaded, the information is loaded in here. All you have to do is select one of the items, and then you define what's X, what's Y, and what's Z. Now, something that surveyors will sometimes do is also put in line codes and point codes. You have the ability to go in and pull this down arrow up and actually define those as point codes or line codes. Okay. Once that's done, then you hit process, and that information is added to this particular file. We also have extract XY or DEM, which is DEM is digital elevation model, and a lot of times people that do drainage work will use DEMs to get a better idea of their drainage areas. And we also have extract set format that uses different types of the TEX, THD information, RT40s from like RDS information, and Casey from other products, information from other products that can also be used. Now we go into the second area here, build DTM from survey data. So if we have that survey data, we're going to go to build triangles. We've created a DAT file, and now we're going to go and build our triangles. So I'm going to select this. You notice that it already put in our DAT file, our class.dat, and we're going to call this 10 file the same. We're going to call it class.10. We also have a side option, and what the side option is, it's called a dissolve option. We're going to use side, and what that does is if I zoom into this area down here in the bottom, you'll notice that there's no data here. Well, what we don't want is we don't want to leave that for any distance, because what will happen is Geopak will try to run a triangle line from here to here and in between these points, and it will give us false information. There is no information here, and so what we do is we come in and say dissolve any triangle leg that's over 150, and that's just an arbitrary number that we use. Any information that's over 150 units long, we want you to dissolve that. All right. Now, whenever I get this information in here, I'm going to hit process, and I'm going to overwrite my 10 because I already had one created. Overwrite that 10. And now we have a 10 file. We have a surface file. Now, some of the other tools we have here are we can build a lattice, we can build merge tens. Okay, so if you want to merge a couple of tens together, you can do that. We have to make sure that they have at least one common point to merge them. You can build clip tens, which means if I have a large tin area, a large project area, but I'm only working in one portion of that project, that I can actually clip this area out. I can build a pad, a delta 10. I can edit triangles. I can edit duplicate points. These are all my edit tools. Edit break lines, filter vertices. I can come in and join linear features, and also do a Z-range clip. Then we have drape vertices, we have drape vectors, we have all of our drape tools, drape elements. Reports, duplicate points. So if we have duplicate points, we can run a report of duplicate points. Crossing features. Report 10 statistics. Now if I go in here and select this particular tool, it brings up this little dialog box, and what this does is it allows us to go in and put in our 10 file, our newly created 10 file called class.10, and when I hit process, what it's going to do is it's going to tell me some important information. It's going to give me how many points are in this particular file, how many lines, triangles, how many break lines, how many voids, but it also gives me the minimum and maximum information for this 10. So if you know that your data, you know the minimum or basic minimum and maximum elevation for the area that you're in, and you run this statistic tool, and it comes up with maybe a 0, then you know that you've got an issue. So what this is really just a quick check to make sure that everything went well. All right? Okay, so we're going to close that out. And we've got other tools. We've got Load DTM Features. We're going to go to this tool right here. We're going to load DTM Features. It gives us our 10 file. We can do it load for extents, which means the entire area. We can load for a fence, which means if I create a fenced area, it'll allow us to load within that fence, or for the view, so that if I have just this view pulled up, it will load information just within that view. I can do for display only, which means that it will not draw it in the file. It'll only display it on the screen. Whenever I update the file, it will go away. And I can set graphic group on so that if I somehow forget to put on display only or toggle on display only, it'll be drawn as a graphic group and it can be deleted as one particular grouping. So let's look at the different information that we can load. We've got our triangles, our 10 hull. The 10 hull is simply the border, the outside border or hull of our 10. And then we have our contours. Right? So let's look at, first of all, our triangles. Now, we have several ways of turning these on or off. We can double click on it to turn it on or off. We can come down and click in this box that turns it on or off. We can come in and turn all items on or all items off with these little light bulbs, or we can turn that particular item that's highlighted on or off. And we're going to turn triangles on, and now we're going to decide what color or what symbology we want to use for this particular, for the triangles. And to do that, we're going to go into this dark area here, double click in that area, and it brings up a set feature box. We go in and pick a particular level. We can pick a color, our line code, our weight, say OK. We've got display only turned on, and then all we have to do is say load, and it loads our triangles. Now remember, we have display only turned on, so if I come in and zoom into this area, then those triangles will go away because they're only displayed. They're not actually drawn into the screen. So if I go into the area around this cul-de-sac, for instance, I can go in and say load, and there are all of my triangles for my surface. If I zoom back out, I can load my 10 hull. I can turn that one off. Go to the 10 hull, turn it on. It's a big white line. I can say load the 10 hull, and you'll see that I've got a border or the border of my 10 drawn. Right. Zoom out a little bit, it goes away. Turn that off, and I can go to contours now. And if I toggle on contours, then I can tell it what my interval needs to be. I can say For instance, my major interval is 2 and my minor interval is maybe 1. Okay, I can do smooth with B-spline or none. If I don't know my minimum and maximum Z, all I have to do is hit the read button and it will go out and read my TIN file and give me that information. But once that's set up, then I can come in and turn on my major lines and labels and also my minor lines and labels. I can go in and set the symbology for the lines and the text of each one of these. I can zoom into this area and I can say load. Once again, we have display only turned on, so it's only going to load it. It's not going to actually draw it into the file. It's going to be in there for display only. And I'm going to say load. And there are my contours. And we can zoom into this area down here. They go away, and I will load them again so we can see them a little better. And there are the contours. Now if I even zoom in farther here into an area, I can go and change this from extent for view. So the only thing I want it to load is just this view. And so if I load that view, you'll notice how much quicker it loads. But there are the contours, there are the numbers, and the different colors that they were set in. Okay. All right, so let's do a fit. And that's loading DTM features, but we have some other options here. Now let's look at some of the other tools we have. We have a height slope tool, and this is right next to load DTM features. It's called a height slope tool. We'll select that. We've got class.10, and I'm going to zoom into an area here so we can look at it a little closer. And what the height slope tool does, it has two different modes. It has a elevation. We'll look at the elevation first. And I can set the text. Double click on this. It gives me that set feature box again. I can set the text. Set those text height, text width. I can set the color, whatever color I want it to be. Let's get something we can see maybe. And say OK. And then I can show the contour, the triangle, and the flow arrow. And I'm going to initially show all these in 3 different colors. And watch what happens when I hit, now this is set on elevation, so watch what happens when I hit the start button and move my cursor into the screen. So it's showing first of all the contour line for 789.01, and it's showing that contour, or it will show that contour. If I zoom out, it shows that contour everywhere it exists in this TIN file, not just where my cursor is. So everywhere that contour for 788.87 exists, it's showing that contour. It's also showing the flow with that blue arrow, where the flow is going. As we move around, you'll see that the flow changes. And it shows the triangle, the associated triangle as I move through here. Now, if I don't want to see the triangle, I don't really need the flow arrow, then I can come in here and all I have is the elevation and the contour that's associated with that elevation. And that is the elevation portion of the height slope tool. Now let's look at the slope option. Now I've got display slope and percent, run rise, rise run, percent, and unit to unit. But I'm going to look at the triangle slope first, and in that case all we have is just percent. Okay, and watch what happens. I'm going to come in here, hit the start again, and put my cursor in the screen. And what you'll see is the X, Y, you'll see in this area, the X, Y, and Z value where my cursor is, and also the slope at that particular location. And it's 708, 260, and you can see it change as I move through here. Now this is set for display only, but if I actually wanted to come in and snap to the corner right there, I could do that and find what that particular slope is at that corner, and it could be placed and would be in there permanently if I had display only turned off. Now the other option here is slope between points, and what this allows me to do is simply say start, hit a data point here, and drag this out to another point, and it tells me first of all the slope minus 3.59, the distance 155.32, and the delta elevations of minus 5.58. Now the purpose of all these analysis tools are basically to give you some information, some design information or preliminary design information that you can use to do your final design. Okay, so we'll go back in here and we've got profile. So if I go to the profile tool, which is the second over from the DTM features, and go to profile tool, zoom out here a little bit, and I'm going to delete this particular one because I'm going to add a new one, and I'm going to go into and find our tin file. Get the right one. Because our class.10, we'll open that up. We'll put in double click here to choose the color that we want for our profile. And then we're going to, before we can do anything else or establish or get a profile drawn, we have to add this information to this collection field. And to do that, all we do is come up and say add list item, and it adds that information in here, and then we can go to the profile part. Now if I zoom out a little bit, I've got two options here. I've got select profile element. Now that means if there's a line actually drawn across here, a microstation line, I can pick that line, or I can go in and place my own line. So if I hit place my own line, I'm going to come over here, hit a data point, hold it down, drag it across this area, and when I let up, then you can see that it shows me the profile of that particular line. Now keep in mind that if you'll notice that particular profile, if I come over and start on this side and go back the other direction, then the profile goes in the direction the line is drawn. Right? If I want to change, I can go to this next profile preference tool, and I can change the I want to say that needs, let's make that 2:1 horizontal vertical. Put that in there, go back, and now it's set at 2:1 instead of 5:1. I can also go into those preferences and set my grid, my horizontal and vertical grid, because I can go in here and place this particular profile on the screen. Now this is not the way that you would normally draw a profile. This is just something that gives you a quick reference and quick information on what's going on in a particular area. So let's look at, we could have volumes, we can compare volumes, elevation difference, slope areas, we can do themes, which gives us slope and percent of slope in a graphic format. In other words, it will go in and put color schemes as to where different elevations exist. We have drainage tools, and this is one of the more used tools in this particular list. If I select drainage tools, the first thing I can do is I'm going to do a fit here. The first thing on the list here is to delineate watersheds. Okay, so if I go to delineate watershed, I can do the watersheds in a particular color. I can do the zero areas and the void areas in a color. I'm going to do this for display only, and I'm going to hit apply. And when I do that, it goes out and reads this area and then puts all of my watersheds on the screen. I'm going to zoom in here because I want to look at this a little closer. They're going to go away because they were all done with display only. And I'm going to say apply again. And there are my watersheds. And you can see the 0 areas here. We've also got delineate watershed. We've got drainage patterns. Most of these you want to make sure you do that with the display only, and I'll show you why. If I come in here and do my drainage patterns, let's zoom in a little closer so we can see. Hit apply. Then it goes out there and reads that TIN file again and draws all of the, it takes a few minutes, draws all of the drainage patterns, where the flow is going. And that's why a lot of times, that's why you would want to use the display only option there, because that will draw a lot of lines in your file. Now let's look at the next tool is called Downstream Trace, and what the Downstream Trace does is simply this. It says, I'm going to hit the apply button, and it says if a drop of water falls here, where is it going to end up? So if I hit a data point right there, it goes to there. If I hit a data point back here, then it goes and ends up there. So it shows you the path the water will take to where it's going to stop. So if it starts here, it's going to end right there. So if I've got rain falling here, it's going to end up right there, and so on and so forth. It's also, there's another tool in here right next to it called an upstream trace, and all that does mean it says if water ends up here, where did it come from? So if I hit a data point, it says the water came from right here. Okay. You have the option to do flow arrows, and another time that you want to make sure that you have this on, and I'm going to do set the arrow size at 5. We're going to zoom in so we can see this a little clearer, and I'm going to hit apply, and you'll see that it's put all these arrows, and those arrows represent the flow and where the flow is changing based on this particular TIN file. We have delineate low points. If I go in here, delineate the low points, say apply, then it puts a LP with an arrow at every low point in the file. I'll zoom in here so you can see this a little bit better. Hit apply, and there are all the low points. Now this is extremely helpful whenever we get to the point where we can go in and create a proposed DTM. Then we can use the proposed DTM and use this tool and locate all of our low points so that we can decide where we need to put our catch basins. It also allows us to delineate the high points. We can do our ridge lines and sump lines, surface ponds information, and pond analysis. Now what pond analysis does is extremely helpful also. If I go to pond analysis, and we're going to draw ponds in blue and the islands if we have any in red, but what it does is when I hit apply, I'm going to use that same tool, the same process that we use back here with this downstream trace. I'm going to hit apply and go over here and hit a data point. And if I hit a data point here, it says that water comes down and creates a pond right there. Right? Now, if I hit apply again, hit a data point right here, then it tells me that the water that fell there is going to go to this location. It's going to create a pond with this many cubic feet as surface area. The pond surface area, rather, this many cubic feet of pond. This is a surface area in square yards. This is the maximum surface elevation and the maximum pond depth. This is almost 3 feet deep. So anywhere you hit a data point in here, once you select this tool, you say apply, hit a data point anywhere here, and it's going to show you and take you where that pond exists. Now I'm going to zoom in just a little bit here. I hit apply button, come in here, hit a data point, and it'll show you a little clearer where that pond exists. And that's where the information, that's going to be associated with that particular pond. So it gives you an idea of where water is going to accumulate in your existing ground information. Okay. We have also have visibility. We have trace slope pass, trench volumes. We can do trench volumes. We have other tools, DTM cameras, locate camera and target. We have other actually camera tools that we can use in a 3D file, which this is. Plus we have convert to 10. Okay, we can convert a 10. We can convert ASCII to binary. Our particular 10 is binary. We convert it to ASCII. We can convert binary to ASCII. We can check our triangulation. Now what check triangulation does, it's just a quick way. If I click on this and I say process, and I go in and put my 10 file in there once it's created, then it just says triangulation valid. So it's just a quick check to make sure that everything worked correctly. We have metric to English. We can export this, export a DTM. We can also import and export land XML data. We can import and export MX data. And we also have LiDAR tools. So if your survey group is using LiDAR information, you have the ability to use the LiDAR tools as well. All right. So that will conclude our look at the DTM tools and how the digital terrain model tools work.